All right, pre-calc, we are going to do lesson 2 of unit 4, which is on circles. So I'm just starting here on the first page of the note packet at that picture at the top, so we can look at that and see where a circle comes from. And a circle is created right here. A circle is created right here when you cut a cone parallel to the base of the cone. So here's the base of the cone. Here is the plane that is slicing through the cone, and the plane and the base are parallel to each other, and that gives us a circle. So going back to, or going up to page 4 of our notes, here we are at circles. So just make a note of that. A circle, when a cone is cut parallel to its base, you have a circle. That's how we get our circle. All right. A circle is the set of all points in a plane that are a fixed distance, which is the radius, from a fixed point, which is the center. The equation of a circle whose center is at HK, that is our standard variables for the center, is written using the Pythagorean theorem as shown below. So looking at this picture, here is our center at HK. Here is a point on the circle at XY. And we draw our right triangle. And in our right triangle, so here's our right triangle, our radius is our hypotenuse. This is a leg right here. And that leg, the measurement of that leg would be the difference of the x values of our 2 points. So we have x minus h. This is also a leg, and that is a vertical leg, so the distance of that leg would be the difference of our y values. So right here, this is our Pythagorean theorem, a squared plus b squared equals c squared. But in terms of a circle, one of the legs is x minus h squared. So that's where the x minus h comes from. Plus, the other leg is y minus k, right there. So that's where the y minus k comes from, equals our hypotenuse c squared, which is r squared. So in order to write the equation of a circle, you need two things. You need hk, the center, and you need r squared. Those are the two things you need to write your equation of a circle. Please notice that since both h and k are transformations inside, so both h and k, the y value and the x value, are inside a square. Therefore, when you do transformations of these equations, you will do the opposite of both x and y. So it's a little different. All right. Example 1, write an equation of the circle with radius 4 and whose center is 0, negative 3. So our center, here's our HK. Radius is 4. So here's our standard equation of a circle. Let's plug in what we know. So x minus 0 squared plus y plus 3 squared equals radius, which is 4 squared. Cleaning that up, we have x squared plus y plus 3 squared equals 16. And there is the equation of the circle. Example 2. We're given this equation. Identify the center and radius. So again, if you write down your equation of a circle and you compare that, you can come up with the center. Here it's a minus h, here we have a plus 1, so therefore this has to be a negative 1 for h. And again, comparing your k's, we have a positive 4 for k, we don't need an equal sign, and then the radius, r squared equals 9, so the radius is 3. Now remember, technically that would be plus or minus 3 in solving that, but a radius is a distance, so it's positive. B, graph the circle. So when you graph a circle, the first thing you want to do is put the center on. And then from that center, you're going to count your radius. Now, remember, the radius is 3 in every direction, but I can't really count the slanted direction. So I'm just going to count the up and the down and the left and the right to get my circle. So I have 1, 2, 3, down 3, to the left 3, and up 3. And I connect those dots as good as I can. I'm sure yours are way better, and there is my circle. So notice the hint. You can count the radius in any direction, so choose to count it up, down, left, and right of the center of the circle. Next page. Suppose the center of the circle is 4, -3, and another point on the circle is -6, 2. Write the equation of the circle. So if this is the center of my circle, that's my HK. What is missing here is the radius. I don't know what the radius is. And remember, technically, I don't need the radius. I need r squared. That's what I'm looking for. So I'm going to write my equation of a circle, x minus h squared plus y minus k squared equals r squared. And I know that gets redundant, but if you write it a lot, you're going to memorize it. And now I'm going to plug in what I know. So I'm going to put this into that equation. So that means I have x minus 4 squared plus y plus 3 squared equals r squared. And you can see in that equation you still have 3 unknowns, x, y, and r. I don't know r, but I do have a value here, another point on the circle that I can use for x, y. So I'm going to plug those in now. And so that gives me -6 minus 4 squared plus 2 plus 3 squared equals r squared. And now I have only one variable, r, and I can find my radius. So I have -10 squared is 100. 2 and 3 squared is 25, is r squared. So 125 is r squared. And that's good enough. I don't technically need to know my radius. I just need to know what r squared is. So plugging that in right into that equation, I have x minus 4 squared plus y plus 3 squared equals 125. And there's my equation of my circle. Example 4. Before we do this, we have to fix a little typo. This should be a 6x, not a 6y. So the problem says prove the graph of this equation is a circle. Then find its center and radius. So I need to do two things. I need to prove it's a circle and then find its center and its radius. Well, in order to prove that this equation is a circle, I'm going to see if I can rewrite it into my standard circle form. So in order to do that, you're going to have to complete the square 2 times. So let's go ahead. The first step in this is I'm going to get all my x value, or all my terms with x in them together, and all my terms with y together in them, and I'm moving my constant to the other side. So that means I have 3x squared plus 6x. So I move my 6x over, and now I'll do my y's. 3y squared minus 24y, and then move my constant to the other side. And now I am going to complete the square for my x's and complete the square for my y's. So looking at my x terms right here, I notice they both have a 3 in it. I will factor that out. And then I'm going to leave a little space for my completing the square. Looking at my y terms, they both have a 3 in them. And I'm going to factor that out. And I'm left with y squared minus, okay, I'm factoring out the 3 from my y's, and I am left with y squared minus 8y, and I leave a space for completing the square, equals 93. And then I'm going to write down plus, because I know I'm completing the square 2 times, and I'm going to have to add both of those values to the other side. And I write down those blanks just to make sure I remember to fill them in. So now the next step. Completing the square for my x's, you take your b value, divide by 2, and square it. So you have 1 squared, which is 1. I write a 1, but truly I'm adding 3 times 1, so I add 3 here. For my y values, I take my b value, divide by 2, which is 4 squared, and I get 16. And I write 16, but truly I'm adding 3 times 16, which is 48. So cleaning that up a bit, I have 3 times x plus 1 squared plus 3 times y minus 4 squared equals 93 plus 3 plus 48 makes 144. Now this is not in standard form. Remember, standard form there's no value in front of your x and your y. So I need to divide out those 3's in order to get it in standard form. So I'll divide every term by 3, and I have x plus 1 squared plus y minus 4 squared equals 144 divided by 3, which is 48. And now that I'm in standard form, I can answer, well, first of all, now that I got it into standard form, I can say, yes, it's a circle. So if I can rewrite an equation into the circle formation of an equation, then I can say it is a circle. If I could not divide these 3's out, for example, if these were different numbers, like let's say this was not a 3, let's say this was a 2, then there is no way to divide out those coefficients. And I would not have been able to get it into the form of a circle. And so I would not be able to say it is a circle. But since it was all the 3, the same numbers in both of those, I can say I can divide out those 3's and I can get it into a perfect equation of a circle. And once I have it in the equation of the circle, I can say the center is negative 1, 4. And I can say the radius is the square root of 48, which is 4 radical 3. There's my radius. Okay, moving on, number 5. Write an equation of the circle whose center is negative 2, 5 and has an area of 81 pi. All right, so remember to find the equation of the circle. You guys getting sick of these equations yet? I need the center, which is hk, and I need my radius squared. 2 things. So I'm told the center right here, but I'm not told the radius, but I am told the area. So off to the side I can say, well, my area of a circle is pi r squared. That's the formula for area of a circle. And in this case, the area is 81 pi. So 81 pi equals pi r squared. Divide out the pi, and 81 is r squared, which is what I need to know. But I also know my radius is 9. So now I can write the equation because I have my center and I have my radius. So I will say x plus 2 squared plus y minus 5 squared equals 81. Remember, you're putting r squared in there, not r. Next problem, 6. A circular fountain with a 5-meter radius. So we have a circle fountain. This is the radius of 5. Lies in the center of a circular park with a 700-meter radius. Calculate the total walking area available to pedestrians visiting the park. So we are going to assume that the walking area is all of this. Okay, so to solve that, to find the area of the walking area, we'll say area of walk is going to be the area of the park minus the area of the fountain. This is the fountain. The whole park is the big thing. And so let's find that. The park, we've already said area is pi r squared. So for the park, we have pi times the radius is 700 squared. And the fountain, the area of the fountain will be pi times, what was it, 5 squared. Which means if you square 700, you have 49 pi minus 25 pi. That will give you 48,9975 pi meters, which is the most accurate answer. Or we can multiply that out for an approximation of 1539301.86 meters squared. So here's your approximate, here's your exact. And that is the end of the notes.